So you're going to find your 4 parts. Technically, tangent doesn't have an amplitude, but that number still matters. So I still note that 2 back there. That's a reminder. Okay, who remembers the change in finding period? It's pi over b, so pi over 3/2, not 2 pi. Okay, so what's going to happen when you flip that? Yeah. Yeah, it's going to be 2 pi over 3. That's nice. Do we have a phase shift?
Yes.
If you've got a quantity, you got a phase shift. And this one we will have to solve. So can I just go ahead and add the pi over 2 over? And so then to solve it, I'm going to multiply by 2/3. So if I multiply that by 2/3, that's a times. The 2's are going to cancel, and I'm going to get 1/3. So we have a phase shift at pi over 3. And I kind of ran myself out of space. Do we have a vertical shift? The vertical shift is 1. Yes. Okay. Which I would recommend you go put on right now. So if the vertical shift is 1,
So the what?
I'm not following the phase shift. We're coming back to phase shift in a sec. Hang on. Okay. I'm also going to mark off the fact that I had that 2 in front. It's not an amplitude, but I got to go up 2 and down 2 off that axis. That one's really wackly bad. Okay. So I know that much. Now we got to go back. You still have to figure your 5 points. Every single time you still got to find the 5 points. How do I figure out how far apart to spread them?
Period times the force.
Yes, still period times the force. So our period was 2/3. So I got to take 2/3 times the force, which will be pi over 6, yes. So our points are going to be pi over 6 units apart. Now, here's the change, and the only time you do this is on tangent. Okay? Corner over there. Devin was being a distraction, yes. Okay. Your phase shift is pi over 3. What's at the phase shift? Nope. On tangent, what shift? The center is normally at 0, so the center is at pi over 3 now. So when you're doing this, the phase shift is the center point. So where do you need your other 4 points to go? You need 2 of them on the right, and you need 2 of them on the left, because that's the middle. So you're going to add pi over 6, and you subtract pi over 6 to go to each side. Okay, so 1/3 is really 2/6. So 2/6 plus 1/6 would be 3/6, and 4/6 going to the right. Going to the left, I'm subtracting the 6. So 2/6 would be 1/6 and then 0. Yeah. So we have an asymptote of 0. Yeah.
Chain to the wall.
So this is actually fairly easy points to find. We have 0 then. 1/6 is a tick mark not labeled. 2/6 is really a third. 3/6 is a half. 4/6 is 2/3. Okay, so this is pretty skinny graph. So when I go to plot it, I have asymptotes then on these endpoints. A little crooked there. Where's the center? Pi over 3, but it's up here on the new axis. That's the center point. Okay, now this tangent rise or fall? Tangent rises. Okay, so I've got to plot those 2 halfway points. One of them's up, one of them's down. How many units up and how many units down?
Up 2.
Yeah. Okay, since the amplitude number was 2, we are up 2 and we're down 2. The left side's got to be down 2. The right side's got to be up 2 units. Whoops, that's not up 2. I came from the wrong place. It's up here. So, oh, I'm crooked. Wow. Try that again. That's a little better. Okay, so that's going to be my points, and I'm just going to go underneath and hit that point. See, go heading toward the asymptote. Come down.
We have to draw multiple of these on the
Okay, tangent, cotangents, if they will fit, you have to draw me two periods. You have at least one on your assignment today that's super wide, and you only get one on. It's like 3 pi wide, so it's going to eat most of your graph paper. But if you can get 2 on, yes, I want you to get 2 on. So how'd you get another one on? Now that you know these points, if this was 1, 6, 2, 6, 3, 6, 4, 6, can't you just keep going? Yeah, exactly. You can go on 5, 6, 6, 6, 7, 6, 8, 6, which would be 8, 6 would be 4/3. So my next asymptote is at 4/3. My next center is at pi. Once you've got one period on, it's easy to find the other point. 5, 6 is that tick mark. I did it again. See, I keep getting off my axis. And so you'll just be up and down, same places. Where am I at? And you got another period of it. Pi is the dead center, yep. 4/3 is the edge. Okay. Because no, because I just went 2/3 was 4, 6, 5, 6 would be the next point, 6, 6 would be pi. It just happened to land there. It's not guaranteed it's going to be a pi. It just happened to land on this one. It landed there. Okay. Question: what if I had put a -2 in front of this tangent? What would have changed? It would flip, so therefore it would look like a cotangent, yeah. So if there's a negative on these, they look like the opposite. But when you shift them, you still shift, on tangent, you still shift the center. If this had been a cosecant, cotangent. If this had been a cotangent, how would you have found the 5 points? If we had been doing a cotangent, that pi/3 phase shift would have been the asymptote. And you would have found 4 more points following it, just like you do sine, cosine. When you do a cotangent, you find the 5 points just like you do on all the others. The only one you do different is tangent, because the center is at the phase shift. Cotangent starts with the asymptote, so you just name off 5 points and keep going. That's the big distinction.
So, on our journal, it says a causes the graph to become a cotangent.
Yeah, you can say it become a cotangent or it causes it to fall. Either way is fine. Yeah. Okay, we are nearly out of time.